Well, in the previous session we discussed about the protection of power systems against internal faults. Today in this session we discuss about the protection of power systems against external faults. The most severe external faults comes from lightning. So today our topic is about lightning and lightning arrestors. The topic is like this: phenomena of lightning, occurrence of lightning, protection methods applied to lightning, types of lightning arrestors and rod gap arrestors, and lastly objective type questions. So in the topic, the first one is phenomena of lightning. So how the lightning takes place? You see the following figure. The phenomena of lightning is like this. Before lightning takes place, the lightning is before the lightning, the picture is like this. So it is a cloud. One is the cloud, and the bottom of the cloud is concentrated with negative charged ions. 2 is the negative charged ions, and 3 is the distance between cloud and earth, and these are the positive charges. Fourth one is the positive charges, fifth one is the earth. So this is the before lightning takes place, the picture is like this. Here the cloud also having positive charges, the cloud also having positive charges. They are on the upper side of the cloud, but bottom of the cloud contains the negative charged particles. Due to this negative charged particles, we call it as inducing charges. Due to this inducing charges, the positive charges are induced on the earth. So these are the positive charges, those are induced on the earth. So why these charges induced? Because of it is electrostatic induction. Due to electrostatic induction, there is a negative charge is there. Due to that negative charge, a positive charge, that is oppositely charged particles are induced on the earth. So this is the picture before lightning takes place, and the lightning takes place like this. You see in the figures. Figure 1. In this figure, as already said about, the ions are, here it is negative ions or charges, here it is positive charges. So what happens? Negative charge and positive charge, there is a force of attraction between these two charges, that is unlike charges attract each other, unlike charges attract each other. So in this way, negative charge and positive charge come close to each other, they are come close to each other. In this way, at certain distance, that is between the cloud and earth, at certain distance, the potential difference or voltage gradient, we may call it as potential difference or voltage gradient, is sufficient to strike an arc between particles, that is the negative particles and positive particles. Due to this arc, what happens? Due to this arc, the air surrounding or between the cloud and earth gets ionized. So what happens if ionization takes place? Ionized is a good conductor of electricity. So in this way, the negative charges all, that is here in the second picture, the negative charges are all come and down to the positive charge, combine the positive charge, and they will, in the third picture, the total negative charges are neutralized by the positive charge. In the last picture, the total negative charges are neutralized by the positive charge. That is, here is said about the arc. So, arc is nothing but a we seen as a lightning. So, this is the lightning takes place. So, what happens during lightning? The total negative charge comes down to the earth, that means high voltage discharge takes place from the cloud to the earth through the ionized path, that is the air gets ionized. So, from this the high voltage is discharged from the cloud to the earth through the air path or ionized path, and this is the actual lightning takes place. So, which parts the lightning takes place? So, the lightning takes place between the following parts also. They are: lightning is an electric discharge between cloud and earth. Second one, between clouds, that is between clouds also lightning takes place. Between the charge centers of the same cloud. Suppose there is a cloud and it has some charge concentrations. Between these charge concentrations also in the same cloud the lightning also takes place. Not only this, but also the lightning takes place between cloud and earth through tall objects like mountain, a building, a tree, and particularly transmission line or transmission tower. So, through these objects or tall objects also lightning takes place. So, these are the types of, these are the occurrence or the lightning takes place, that is the process or phenomena of the lightning takes place. So, next one is where it occurs, but it occurs so many where, but our more concentration is on the power systems. So, in respect with the power system, we will discuss about the occurrences of the lightnings on the power system. So, there are three types of occurrences. So, first one is overhead line struck by lightning immediately adjacent to generating station or substation, that is the lightning is directly upon the generating station, substation or substation. It will directly hit the generating substation or substation. So, the figure is like this. So, here it is a generating station or substation. 2 is the generating station, substation or other substation. So, 1 is the lightning hit. So, here the lightning is hit to the directly hit to the substation. So, what happens if we not protect any protection? It simply damages, completely damages or partially damages the generating station, substation or substation, because the voltages, that is we call it as high voltage or surges or over voltages, these are due to the lightning surges or lightning over voltages. This high voltage is very much, you know that voltage, this is around 20 megavolts to 100 megavolts. The voltage, lightning voltage is 20 megavolts to 100 megavolts against our normal system voltage. How much our normal system voltage is? 33 kilovolts, 66 kilovolts, 132 kilovolts, 220 kilovolts, 400 kilovolts, etc. So, how much the lightning voltage is there? 20 megavolts. Minimum voltage you take 20 megavolts. This 20 megavolts hit the power system. What happened? Generating station, substation or substation. The equipment in the generating station, substation or substation completely damaged, because this high voltage first damage the insulation of the equipment. Due to this, what happens? Short circuit takes place. Due to short circuit, a fire hazards may or completely damage that equipment. Not only that equipment, it will extend it to other equipments, so that the total substation may damaged. So, we need a protection against this type of lightning strokes also. And next one is tower or earth conductor struck by lightning stroke. Here another occurrence is lightning stroke hit by the tower or earth conductor. The figure is like this. Here it is a tower. This is single circuit tower. Here it is conductors, and one is the earth conductor where the lightning hit here, because the lightning always hit at the top of the object. This is the tower is the tallest one. So at the top one is the earth conductor or it is a tower. So where it is hit here, and it is a 2 is the line conductor and 3 is called as backward flash. Suppose a lightning hit at the top of the tower, what happens? A high voltage that is produced on the conductor. It has a path like this, because it always, the lightning voltage always choose a path, lowest path. Here it is the lowest path. So in this way the lightning voltage comes like this, and at this point here you see, here is lightning voltage, that means it is travel like this. At this point here it is a lightning voltage somewhere around 20 megavolts or 10 megavolts. It is a 10 megavolts or 20 megavolts, and here it is a normal system voltage, the conductor carrying normal system voltage. Due to the potential difference between these 2 points, that is point this and point this, there is an arc produced between this gap. Due to this arc, what happens? These are the insulators, we call it as discs. These discs may get damaged due to this arc. Due to that, what happens? The current or the voltage leaks from conductor to the metal pin of the discs, and like this it has always leaks like this. Due to this also shock may be observed. Not only that, due to the arc, a backward flash, that is the voltage produced on the conductor, and this voltage travel in both sides, both directions, towards and against the substations, and also it reaches the that voltage reaches the generating station or substation. The equipment at there also gets damaged. So this is the other type of the occurrence of the lightning over tower or earth conductor. So here also we will protect properly. And third occurrence is the third occurrence is like this. Third occurrence is the lightning hit substation at a long distance on the transmission lines. That is, the lightning struck at a long distance on the transmission line. Due to this, what happens? A high voltage produced on the transmission line conductors. Due to this, a travelling voltage travels. We call it as a travelling voltage. The high voltage that produced due to lightning, call it as high voltage or travelling waves. The travelling waves comes towards the substation, and figures is like this. Here it is transmission line conductor, and it is line where the line hit by the lightning stroke. 2 is the lightning stroke hit by the transmission line, and 3 is the direction of the travelling waves towards substation of this substation and towards another substation. So the direction of the travelling wave is like this, and here also the voltage of the travelling wave is like minimum of 20 megavolts. Due to this, what happens? This lightning voltage comes to the generating substation or substation. It will damage the equipment in the substation. So what happens? It may damage completely or partially. So these travelling waves are also damages the power system equipment. So in this way we will also need protection against these occurrences of the lightning also. So next one is protection methods applied according to the occurrences of the lightnings. Those are, first one is types of protection against lightning. First one is earthing screen or shielding network. So here is earthing screen or shielding network. This is applied to the occurrence of the lightning directly upon the generating station or substation directly. And second one is overhead earth wires. Second one is overhead earth wires. Here it is, this is applied to the transmission line towers, that is the top of the transmission line we provide a earth conductor, and this earth conductor is properly earthed. So this is the protection against the lightning stroke struck by the transmission line tower or earth conductor. Third one is lightning arrestors or surge diverters. Third one is lightning arrestors or surge diverters. These are used for the protection of the generating substation or substation equipment against travelling waves. So these are the protection methods applied according to the occurrences of the lightning. So first one is like this. The shielding network is like this, or earthing network. So one dash, one double dash, and this way, and these are all the called as earth electrodes, and two is the earth ring. So this is always placed upon the highest point upon the substation, that is inside, that means on bottom side the equipments are placed. Here the equipment, that is the power system equipments, these are the power system equipments, these are all the below, and over this equipments the earthing network is done. This is another earthing network. So here also we will provide earthing networks, but it is not seen here because of clarity. So third one is these are the overhead earth wires coming from the towers. Either this side also towers and this side also towers. So earth conductors coming like this and connected to the earth ring. Similarly, this side also earth wires are connected, and these earth wires are connected to the tower. So C stands for circuit breaker, I stands for instrument transformers, P stands for power transformers, C stands for circuit breakers, I stands for instrument transformers, C stands for circuit breakers, and L stands for lightning arrestors. So this is the actual figure of the substation above the equipment. So this is the top of the equipments overhead. So suppose here any lightning stroke directly hit the substation, what happens? You see the figure. Suppose lightning struck over this place. So anywhere, suppose the lightning hit here in this earth wire, what happens? The voltage produced on this earth wires or shielding network wires, this will goes like this. That means this will discharge like this. It will always choose a lowest distance path. Suppose here it the shielding network here, it will go like this and discharges. That means it will protect the power system equipments against directly hitting the substation or generating station equipment. So in this way we will protect the generating station or substation equipment by providing the shielding network. And second one is earth wires or earth conductors. So this is like this. There are two towers. This is the single circuit tower, this is the double circuit tower. These are the conductors, three phase conductors. Here also one of the three phase conductors, here also other three phase conductors, and top of the tower is the provide earth conductors, and it is there is a two conductors here because there is a double circuit. This is one earth conductor and this is the another earth conductor. Suppose here the lightning stroke hit transmission line tower or earth conductor. So the voltage produced on the earth conductor is diverted like this and through earth. If you properly earthed, and it is always discharged to the earth, and we will provide sufficient distance between the tower and conductor, the distance, sufficient distance, and here also we avoid sparks or arcs. We will not any arcs produced here by providing sufficient distance. And here also it is called as protection angle, alpha is called as protection angle. Like this we will protect the transmission line tower against the lightning stroke hit the transmission line tower or earth conductor like this. And third one is lightning arrestor. Lightning arrestors. The lightning arrestors are used for the protection of the power system equipments against travelling waves. So, what is a lightning arrestor? How it is connected? So, a lightning arrestor is a protective device. A lightning arrestor or surge diverters. We may also call as surge diverter because it divert the surge or high voltage. Surge diverter is a protective equipment or device which conducts the high voltage surges on the power system to the ground or earth. So, the lightning arrestor is a device, protective device which conducts the high voltage to the earth, only high voltages. And how it is connected? It has a two terminals, one is connected to the earth and other one is connected to the line. So, the lightning arrestor is across earth and line conductor. So, like this the lightning arrestors are connected. Next one is types of lightning arrestors. The types of lightning arrestors are like this. Types of lightning arrestors are surge diverters. First one is rod gap lightning arrestor. Second one is horn gap lightning arrestor, and third one is expulsion type lightning arrestors or protector tube. Fourth one is valve type lightning arrestors or non-linear lightning arrestors, and we may also call as direct type lightning arrestors. So, these are the types of lightning arrestors. So, the first one is rod gap lightning arrestors. The rod gap lightning arrestor is like this. The figure of the rod gap lightning arrestor is like this. So, this is the rod gap lightning arrestor. First one is the line conductor, second one is the insulator bushing, third one is the transformer tank, fourth one is the earth conductor connected to the earth. So, this is the rod gap lightning arrestor. The construction of the rod gap lightning arrestor is like this. There are two rods are there. These two rods are 1.5 mm diameter, 1.5 mm diameter, and bent like this and provided one is connected to the line conductor and other one is connected to the earth point to the through the earth conductor, and here it is a gap, there is a gap, the gap length is L, and also there is a distance between the porcelain bushing, insulator bushing to the axis of the gap, that is L1. So, this L1 always greater than L by 3, the distance of the L1 is always greater than the L by 3. So, this is the construction of the rod gap arrestor. So, how it works? Working of the rod gap arrestor. Working of the rod gap arrestor is like this. Under normal working voltages, the working voltage here it is in the line is connected inside and it is go to the outside, this is, and this outside is connected to the transformer winding. So, normal working voltage, the line voltage is pass like this to the winding and it is not like this because there is a gap and the voltage across this point and this point, this is earth point, it is not sufficient to produce an arc, because the line voltage is not sufficient to produce an arc between the gap. But for high voltages, and this high voltages due to lightning, that high voltages appears across this rod and also earth point. So there is must be a potential difference between these two. Due to that potential difference is sufficient to produce an arc between the gap. Due to the arc, what happens? The air between the two rods gets ionized. So ionized air is a good conductor of electricity. Therefore, the high voltage that struck the arc, and this high voltage is diverted to the rod and to the earth. That is, the high voltage comes from line and it is enter the upper rod to the ionized path to the lower rod, and lower rod to the earth. So the high voltage is diverted like this, and it will not goes like this to the winding. Therefore, the winding of the transformer is protected against the lightning voltages or travelling voltages. Like this, the rod gapper is working. Of course, the lightning arrestor has some limitations. The limitations of the rod gap arrestor is like this. Limitations of the rod gap arrestors. First one, after the surge is over, that is high voltage discharge is over, the arc in the gap is maintained by the normal supply voltage, leading to a short circuit on the system. That is, once arc is established between the rods, due to this arc any sufficient minimum voltage is sufficient, to maintain the arc. So due to this, under normal supply voltage also the arc will maintain. Due to this, a short circuit takes place. This is the one disadvantage, one limitations of the rod gap arrestor. Second one is the rods may melt or get damaged due to excessive heat produced by the arc, right. So here once arc is established, arc is nothing but heat, high temperature heat. Due to this heat, the rods may melt. So rods melts, what happens? The effective length L increases. Due to increasing of the length, it will not properly protect the transformer winding against travelling waves, because the length is more. Of course, the voltage appears across the rods is not sufficient to establish an arc due to increased length. Due to increased length is due to because of the melting of the rods due to the previous arcs. Third one is the climatic conditions affect the performance. The climatic conditions are temperature, rain, humidity. If at the time of rain or at the time of temperature, over temperature, or at the time of humidity also affect the performance of the rod gap arrestor. This is one limitation. And fourth one is the polarity of the surge also affects the performance of this arrestor, or surge voltage varies with the polarity. That means polarity means positive, negative, depending upon the entering of the high voltage. First it enters the top rod, that is connected line rod, and then it is discharged to the earth rod. So the polarity between these two rods also affects the performance of the rod gap arrestors. So these are the limitations or disadvantages of the rod gap arrestor, but it has one advantage also there. The advantage of the rod gap arrestor is like this. It can be used as backup protection. So types of protection, we are already know about the types of protection. First one is main protection or primary protection. Second one is the secondary protection or backup protection. So some costly equipments are provided, two types of protection, primary protection and backup protection. Here primary protection fails, backup protection protect the equipment. So these rod gap arresters are used as backup protection. So these are the advantage of the rod gap arresters. So up to now we will discuss about the phenomena of the lightning, occurrence of the lightning, protection methods applied to the occurrence of the lightnings, and types of lightning arresters. In types of lightning arresters we cover the rod gap arresters and its advantages, disadvantages and its application. And you may ask now your doubts or questions. Most of the lightning strokes are due to dash charged clouds. A. Positively, B. Neutral, C. Negatively,
Hello?
D.
Hello?
None of the above.
Hello?
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 Speak.
Is the lightning arrestor and the insulator is same, or any difference between lightning arrestor and insulator?
Right. Yes. The question is, the lightning arrestor we may call as a insulator. The question is like this: the lightning arrestor may call as insulator? No. The answer is no, because up to normal voltage the lightning arrestor acts as insulator, but after or during over voltages or surges it will act as conductor, because the high voltage discharged through the lightning arrestor to the earth. So at that time it acts as a conductor. So first it is insulator, then it acts as a conductor. So that's why we may not call as insulator, but we simply call it as lightning arrestor, because lightning arrestor have peculiar characteristics or peculiar behavior. That's why we will not call as insulator. It is only lightning arrestor, right? So the question, objective question is, most of the lightning strokes are due to dash charged clouds. Positively, A. Positively, B. Neutral, C. Negatively, D. None of the above. The correct answer is most of the negatively charged, as already seen the figures you are. And second one is, surge voltage originate in power systems due to surge voltage, that means high voltage. A. Lightning, B. Switching, C. Faults, D. Any of the above. So over voltage originate from
Hello?
any of the above.
Hello?
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 Hello, speak.
Can you give some examples where rod gap arresters will be used?
The rod gap arresters are used, okay. The question is where the application of the rod gap arresters used, because it has so many limitations. The rod gap arrestor has so many limitations, that why these are used for over the transformer, distribution transformer. These are connected across the distribution transformer phases, that is 3 phases, 3 rod gap arresters are connected. There distribution transformer, there we will use the rod gap arresters. Next, surge voltage originate in power system due to any of the above. Due to lightning, over voltage produced. Due to switching also, high voltage produced. Due to faults also, high voltage produced. So the correct answer is D, any of the above. And third one is, the most severe surges on the line are produced by A. lightning, B. switching, C. closing, D. none of the above. So most severe surge is due to lightning, that is A. And next one is, the dash lightning strokes are very rare on the power system. A. indirect, B. direct, C. both A and B, D. none of the above. So the strokes are very rare are direct strokes, that is B. Direct strokes are very rare. And next one is, against direct strokes, dash are used to protect the power system and its equipment. A. valve lightning arrestor, B. shielding, C. expulsion lightning arrestor, D. none of the above. The correct answer is shielding. For direct strokes above the substation, a network is provided, that is called as shielding. And next one is, the lightning arrestor is usually connected. A. in series with the line, B. between line and earth, C. both A and B, D. none of the above. So the lightning arrestor is connected between line and earth. So B is the correct answer. And next one is, rated voltage of the lightning arrestor is A. line voltage, B. phase voltage, C. 3 into line voltage, D. 3 into maximum voltage. So the lightning arrestor is connected between line and earth.
Hello?
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 Yes?
Why lightning arrestors will be used only at the beginning and end of the transmission lines?
Because at the beginning and at the end, two sides we are used, because the lightning voltage has, it will travel in any direction. So first it will enter the first substation, first one hit. So at the beginning will provide, so lightning arrestor at the beginning provide that voltage, that traveling voltage will divert it to the earth, and this side also will provide lightning arrestor. In this side also lightning arrestor travels and hit the substation equipment. Anytime it will hit the equipment. So either side will provide the lightning arrestors. So the lightning surges are diverted to the earth because of the interest of the saving protection of the equipment will provide on both sides, so that the voltage diverted to the earth, right. So rated voltage of the lightning arrestor is, so it is connected between line and earth. So the correct answer is B, that is the phase voltage. Next one is, in outdoor substation, the lightning arrestor is placed near to the isolator, current transformer, power transformer, circuit breaker. So the correct answer is power transformer. And next one is, lightning arrestor is used A. for limiting the short circuit fault current, B. to provide path to high voltage surge to the earth, C. to reduce arcing, D. to reduce voltage. So the correct answer is B, to provide path to high voltage surge to earth. Next one is, lightning arrestor operates at voltage A. any voltage, B. system RMS value of the voltage, C. system peak value of the voltage, D. prefixed voltage. So the lightning arrestor is operates at only prefixed voltage. That is D is the correct answer. Next one is the equipment prefixed to be protected by lightning arrestor in a substation is A. reactor, B. circuit breaker, C. power transformer, D. current transformer. The correct answer is C, that is the power transformer. And next one is the range of the lightning currents from 10 kiloamperes to about dash kiloamperes. A. 30 kiloamperes, B. 60 kiloamperes, C. 70 kiloamperes, D. 90 kiloamperes. The correct answer is D, 90 kiloamperes. And next one is dash cannot protect the equipment from the travelling waves reaching the equipment. A. lightning arrestor, B. HRC fuse, C. isolator, D. ground wires. So the correct answer is ground wires. Ground wires cannot protect the equipment from the travelling waves. It only protect the direct hit of the lightnings only. Next one is a surge diverter should be located dash to the apparatus to be protected. A. close, B. far, C. any place, D. none of the above. The correct answer is close or near to the equipment. And next one is rod gap arrestors are connected across a conservator, B. bushings, C. breather, D. explosion vent. So rod gap arrestors are connected across the distribution transformer bushings. The correct answer is B. And next one is rod gap arrestors are employed as A. primary, B. main, C. backup, D. switch. So rod gap arrestors are employed as backup protection only. And next one is in a rod gap lightning arrestor, the distance between the gap and insulator must not be dash than 1/3 length of the gap length. A. more, B. less, C. higher, D. none of the above. The correct answer is less, that is B. So insulator must not be less than 1/3 length of the gap length. So these are the some objective type questions. So up to now, this is in this session we are discussed, and in the next coming session we will discuss about other types of lightning arrestors, that is the 3 other types: valve type, expulsion type, arm gap type lightning arrestors. Now we will conclude this.